Let's take a look at the next example in your textbook. Here, the sample space S is the ordered pairs of two whole numbers, the first from 1 to 3 and the second from 1 to 4. So they give you an example, parentheses 1, comma 4. So we're talking about ordered pairs. If you remember from algebra, you may recall from algebra, these are that XY ordered pairs that we would use to plot on the Cartesian coordinate plane. So X is 1 and Y is 4. But we're just going to list them out as ordered pairs. And so let's start out. Sample space S is the ordered pairs of two whole numbers. The first from 1 to 3 and the second from 1 to 4. So let's start out, starting with our set notation with the curly bracket. Let's start out with 1. The first number starts at 1 and goes up to 3. The second number starts at 1 and goes to 4. So I'm going to start with 1, 1, right? First number starts at 1, second number starts at 1. Now, to make sure that we get them all, let's do this in a pattern. Let's make sure that we're capturing all of the numbers possible that we need in this situation. So instead of changing that first number, I'm going to keep that first number as a 1. And I'm going to run that second number. I've already got the 1. I'm going to run it up to 4. So let's go 1, 2. And let's do 1, 3. And then 1, 4. Okay? And so first number is 1. And then the second number goes from 1 up to 4. And then, now let's change that first number. We've done all the ones that start with 1. Let's now write them that start with 2. So again, moving that second number, 2, 1, 2, 2, 2, 3, 2, 4. And that first number goes up to 3, so we need one more set that looks like the others, except the first number is different. 3, 1, 3, 2, 3, 3, and 3, 4. Okay, to start part B, let event A equals the sum is even. So A is going to be all of the events, or all of the outcomes, where the sum of those two numbers is even. I'm going to ignore B right now. Okay? So sum is even. 1 plus 1 is 2. 2 is even. 1 plus 2 is 3. Not even. 1 plus 3 is 4. That's even. 1 plus 4 is 5. Not even. 2 plus 1, 3. Nope. 2 plus 2 is 4. That's even. 2 plus 3 is 5. Nope. 2 plus 4 is 6. Even. 3 plus 1 is 4. That's even. 3 plus 2 is 5. Nope. 3 plus 3 is 6. 3 plus 4 is 7. Not even. So 1, 2, 3, 4, 5, 6 outcomes in event A. And I am writing it over to the right because I know I'm not going to fit it in those blanks at all. So that's our event A. Let's talk about B. B, the event is the first number is prime. So what do we mean by prime numbers? Oh, this is really digging into those algebra skills. So a prime number is any number whose only factors are 1 and itself. So the only way we can multiply and get that number is if we multiply that number by 1. A simple example is 2. 2 times 1 is 2. There aren't any other numbers, whole numbers, that if I multiply them together, I get 2. If I move up the numbers just a few, let's take a look at 6. 6 times 1 is 6, but 2 times 3 is also 6. So 6 is not prime. Remember what I said, prime has only 2 factors, itself and 1. Okay, so 1, the number 1, is actually a super special number that is not considered prime because it has only one factor, itself. So it's the only number that is neither prime nor the other word, composite. 6 is a composite number. Okay, so for the event B, the first number is prime. We're going to ignore all of those, all of the ordered pairs that start with 1 because 1 is not prime. And we're going to write down the rest of them because 2 is prime. 2 times 1 is 2. That's the only way we can get 2. And 3 is prime. 3 times 1 is 3. And that's the only way we can get 3. Okay? Our events, A and B. And then part C asks us, what's the probability of A occurring? If we were to put these ordered pairs in a hat and draw one out, what's the probability we get an event that's sitting in, or we get an outcome, we get an outcome that's sitting in event A? And so remember from your probability definition, we're going to divide the number in A by the number in S. How many outcomes do we have in event A? 1, 2, 3, 4, 5, 6 outcomes. And then in S, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes in S. Now I know this book says don't reduce the fractions. That actually makes me crazy. 6 over 12, what is that? Well, if we reduce it, 6 divide by 6, divide by 6. Notice I'm doing the same thing on the top and the bottom. So I'm really just multiplying by a special factor of 1. Okay? And to do this, because I'm multiplying by 1, I'm not changing the problem. I'm just changing the look of the problem. So 6 divided by 6 is 1, 12 divided by 6 is 2, or you can just stick it into your calculator, you get a decimal number, 0.5. It's 1/2. So the probability of getting an event from A is 1/2. Not too bad. Similarly, probability of B occurring, we're going to play this same game. Number in B divided by number in S. So we already counted S. S is 12. I'm going to go ahead and write that down. S doesn't change. But B, 1, 2, 3, 4, 5, 6, 7, B has 8 outcomes. And so we end up with 8 out of 12. But similarly, 8 and 12 have a common factor. We're going to divide by 4 on the top and the bottom. So 8 divided by 4 is 2. 12 divided by 4 is 3. If you put this into your calculator, I want you to be really, really careful though, because the calculator gives you 0.66666, and then it'll end on a 7. Or if you have some fancy calculators, it may put a bar over the 6. And this just means that this decimal goes on forever and ever, and it never stops. So 0.6 repeating is not the same as 0.7. So we don't want to round it. We're just going to leave it as a fraction, 2/3. Similarly up here, we'll just leave it as 1/2. My general rule of thumb in doing these types of problems is if the denominator is 10 or less, we'll keep the denominator as it is. Okay? But that gets you started with probability and events. And we will pick back up at part D in our part 2 of this video.